In laws of motion, we are going to discuss about three laws, Newton's laws. Newton's three laws of motion. So, what are those? Can you tell me? Can you discuss with me? Laws of motion. Okay. Newton's first law, Newton's second law, and Newton's third law. Newton's first law, Newton's second law, and Newton's third law. Okay. So these three laws we'll discuss today live class. Newton's first law. So Newton's first law about inertia of rest, inertia of motion, inertia of direction. It is first law about completely about inertia. Inertia is nothing but unless sectional force acting on the body does not change its position. That does not change its state. So we can say. So inertia three types: inertia of rest, inertia of motion, inertia of direction. So what is inertia of rest? Unless sectional force acting on the body does not move from its rest position. Best example, if you are taking a book on the chair, table, so unless sectional force acting on it, it does not move. Okay, so table if you take, so we have to apply more force to displace the object. Understood? And at the same time, one more thing, fruits. If you shake the branches, so branch of the tree, the fruits will fall down. So fruits will fall down due to inertia of rest. The fruits will fall down. Branches will come under motion, but so the fruits will remain in the same place. So that's why it falls down due to inertia of rest. And if you are sitting in the moving bus, suddenly if the bus driver apply brakes, what happens? So we will fall forward. We will fall forward. Why? What is the reason? Because so our legs are our legs are contact to the body like bus ground. Our bodies, our upper bodies in under the moving condition. So our lower part legs are contact with the ground. So like a bus. So then, so that's the reason. That is the reason automatically we will fall forward. So due to inertia of rest, the legs are comes to contact with the ground, but still the body is in motion. Body is in motion. That is the reason we will fall forward. And one more example, carom. So like you can see the coins, carom coins. So if you hit the bottom coin will move forward. The bottom coin will move forward. इंग्लिश के देवता इंग्लिश का देवता मेरा फेवरेट. So the bottom coin will move forward. So remaining all coins will stay at the same place. Stay at the same place. So that is one point. And one more point you can see. So another point. You are taking the all papers are there like a bundle. If you are taking a one paper in middle of all the papers, then remaining papers will stay at the same place. Okay. So the one paper will take out. That one paper will take out, remaining papers will stay at the same place. And one more example we can take, a carpet is there. Carpet. So if you are taking the carpet, okay, so hit with the stick. So if you hit with the stick, then carpet comes under motion. Carpet comes under motion, but the dust particles will be remaining at the same place. So the dust particles will stay in the same place, right? Yes. So that is about that is an example for That is example for inertia of rest. Okay. So next, one more thing we can go with that, inertia motion. Inertia motion example also we can go, we can discuss inertia motion. So best example, you are taking the fan. Okay, so once you off the fan, what happens? If you off the fan, still the fan will continue rotating. So will continue rotating. Why? Because the body is in motion. Body is in motion. Even though you apply force, but still it will continue in the same motion. Okay, so continuously rotating. That is example for inertia of motion. Inertia of motion. So please share this video to everyone, and so let everyone knows the live class, about live class. So that is about inertia of motion and inertia of direction. So take a stone, tie the thread and whirl like this. Then what happens? If you leave like this, it moves in a particular direction. It moves in a particular direction. Best example during rainy season. So the bicycle. So along the wheel, the water droplets will move. So along the tangential direction, the water droplets will move. That is inertia of direction also. Inertia of direction. Okay. So this all example for inertia. So types of inertia we are discussing. And next one will go with the force. So what is force? So force is nothing but the external force. A push or pull of an object is called force. So in force there are two types: balanced force, unbalanced force. Balanced force means, so equal amount of force, equal magnitude of equal magnitude. So 5 Newton apply. So both say equally in opposite direction, then the body does not move. So and one more thing we can go with that. Uh, so if you are taking 10 Newton and 5 Newton, so along the 10 Newton force only the body will move. Unbalanced force. This is unbalanced force. Coming to the contact force and non-contact force. Contact force example: frictional force, tensional force, muscular force. This all example for contact force. By applying the, by contact of two bodies, the force will act, then only the body will move. Best example, friction. Okay, so if the both the bodies are contact only, the force will act. And coming to the non-contact force, what are the non-contact forces? Non-contact force example means, so gravitational force, electrostatic force, and we can also say magnetic force. Magnetic force. So magnetic force means at certain distance only the bodies will attract. North pole, south pole will repel. Sorry, north pole, south pole will attract. North pole will repel. South pole will repel. North pole will repel. South pole will repel. South pole will attract. So these are the examples for non-contact forces. And impulse. What is the impulse? So the product of force and time. The product of force and time is called impulse. The product of force and time is called impulse, right? Impulse. And impulsive force, large force acting in a small interval of time, that is called impulsive forces. Large force acting in a small interval of time is called impulsive forces. Clear? Understood? Got it? Yes. So next one will go with the law of conservation of linear momentum. Linear momentum means collision before momentum before collision equal to momentum after collision. That is the law of conservation of linear momentum. Law of conservation of energy. So energy before collision is equal to energy after collision. Okay. So that is about law of conservation of linear momentum and law of conservation of kinetic energy. So next one, Newton's second law. Newton's second law is nothing but, so please do kindly subscribe my channel and share the everyone, so to get know by, so everyone knows that channel. So it's related to physics. Okay. So now we can go with that. What we can say? Newton's second law. Every action there is equal and opposite reaction. Every action there is equal and opposite reaction. So F equal to, that is Newton's third law. Every action there is equal and opposite action. Newton's third law. Newton's second law is nothing but, so the net external force acting on the body is equal to, the net external force acting on the body is equal to rate of change in momentum. net external force F equal to rate of change in momentum mv minus mu by t, final momentum minus initial momentum by time taken. That is a Newton's second law. So I hope it is very clear. So that is about Newton's third law, Newton's second law. So that is about the laws of motion. So if you like this content, do like, share and subscribe to Student the Brand. So until that time, we'll see. Thank you.